Welcome to this video, which is an explanation of the operation of our final project of control of electric motors. The theme on which the realization of this project focus falls on the need to reduce the starting current of an electric motor during the startup. As seen throughout the motor control course, there are different types of configuration that help us achieve this goal. However, in this presentation, we will only talk about the start or reduced voltage of a three-phase electric motor using resistor. The The following slide shows a summary of the content to be displayed, objective, simulation, calculation for resistance, physical implementation. The main objective for the realization of this activity can be seen in the image on the left, where different types of connection for the start of an electric motor are shown. It should be noted that each configuration has advantage and disadvantage. So for a low voltage start with resistance, you have the advantage that the connection are easy to carry out, but on the other hand, calculation that will only be useful for specific elements, which leads to resistance being expensive and somewhat difficult to achieve. In this way, the main objective of this video and the activity is prepare the pertinent connection to obtain a reduced voltage start in a three-phase motor using resistor and contactors in order to obtain a start during the first 4 seconds as 70% of the current at full voltage for later for another 4 seconds have 70% of the 50% of full voltage current. In the simulation, you can see the figure on the left, the control diagram, which contains the safety elements such as thermomagnetic switch and thermal relay, in addition to the electric motor contactors and resistors. In the control diagram are devices such as contacts with their calls, start and stop buttons, and timers. The operation of the system can be seen below, which begins with the interlocking of TM3 and timer 1. Therefore, the modification of the contacts. In this way, you have the power supply at 70% of the full voltage expanding per second. The timer modifies the contacts, feeding the second timer, unlocking the KM3 coil and feeding the KM2 coil. After another 4 seconds, the timer modifies its contacts, unlocking the KM2 coil and interlocking the motor at full tension by means the KM1. In the simulation of the video on the right, you can see that there are alignments that do not allow the coils interlocking at the time that they should not. For example, it restricts to KM3 not being enclaved when the KM1 and KM2 coil are interlocked. It also worth mentioning that the operation of the stop button is observed. In the following slide, we can see the calculation of the resistance. And the first point, we have the calculation of the resistance, the value of the resistance using 70% of full voltage. And in the next step, we can see the 70% of the 50% of the full voltage that we calculate the resistance and the power absorbed by the resistance. This operation we can see on the document related to this project. In the following slide, there is a demonstration of the realization of the control diagram of the system where solid-state relays controlled by a microcontroller are used. It is worth mentioning that the physical implementation and force diagram is complicated due to the difficulty of obtaining the resistance in addition to the cost and the range of application that can be given. In this way, ends the explanation of the project elaborated in order to observe and calculate the components in a star reduced voltage of an electric motor.